All right, let's go ahead and take a look at page one of our review. We'll just do one page at a time, I think kind of makes sense. So let's see what we got going on here. So here is just a nice little copy of our review. Hopefully I'm not too far away. So notice we actually are asking you over here to draw the diagram, and we're going to do something similar to that on our test. So hopefully we gave you enough room here. Now this says draw a quadrilateral, and it doesn't say anything particularly special about this quadrilateral. It just says a quadrilateral, so four sides. So I just kind of tried to draw something random, TUVW. And again, since it was random, if my numbers don't look right, we can be a little bit forgiving because we have some facts that we know are true of all quadrilaterals. And since it's not a parallelogram or something, it just should be okay. So this says angle V right here is 51. Now, mine doesn't look like 51, but that's okay. Angle, oh, wait a minute. I did that wrong. That's V is 51. That's right up here. I've already messed up. What do you know? Let me fix that because my V looked like a U. Okay, U is up here at 94. That actually feels a lot better. And W down here is 67. Well, I fell apart on that one. But we know that what we have is every single time you have a quadrilateral, the sum of these angles should be 360 degrees. So I'm going to start with 360 degrees, and I'm going to subtract off the 94, the 67, and the 51 degree. And I'm going to grab a calculator real quick because I don't have that one on the top of my head. But let's see what we got. We're going to start with 360, take off the 94, take off the 51, and take off the 67. And it looks like I have a total of 148. And of course, since that would be the measure of angle T, right? I would say I would probably encourage you to then try it again and say 148 plus 94 plus 51 and plus 67 should be 360, just in case I did something silly, which I do quite frequently. Okay, in the next parallelogram, it says QRST. So I am going to be a little bit more careful with this one, but I'm going to manipulate something. I'm just using a little straight edge because it just helps me a little bit. I'm going to go 0 to 7 on this one, and I'm going to use the same 0 to 7 because one thing that we know about parallelograms is that opposite sides are not only parallel, they're also the same length. So here's my nice little parallelogram. And it says one of the angles is 63.7, and it says QRST. But it says I want to know the measure of angle T. Well, there we go. We have a nice little fact that the opposite angles in any parallelogram are always congruent. So that tells me then that the measure of angle T would be 63.7 degrees. The fact that it's a decimal doesn't really make it any harder. It's just a number, just like anything else. Okay, moving on to my next one, I have a rhombus. Now remember, you got to remember the definition of a rhombus. A rhombus is a figure where all the sides are the same length. So again, not like it really matters that much, but I'm going to go ahead and use my ruler to my benefit. And I made that segment 4 units long, and I'll maybe make this one 4 units long. And we did talk about how in a rhombus, it's also a parallelogram. Now, again, you don't have to actually be this precise. I just tend to be a little sloppy, so I'm trying to be a little extra nice right now. So I made them all the same length. And I have J, K, L, M, and it tells me the distance from J to K up here is 3x plus 9. And the distance from K to L over here is 11x minus 7. Well, hey, you know what? It's a rhombus, so all of the sides must in fact be exactly the same length. So these two things have to be the same. So let's go ahead and set those things equal. Now we have a little variety here. I personally think I would take 3x from both sides to try to move those together. So the 9 is here because those canceled. I'm going to go ahead and add 7 to both sides to get a little bit tighter. So I've got 8x is 16, and now I can divide and I find out that x is 2. Now, we typically kind of just stop there and go, awesome, we finished, x equals 2. But it says, what is the perimeter. Wait a minute. I need to find all of these things added together. I don't even know what any side is yet. But that's okay. What is 3 times 2? Well, 3 times 2 is 6, and 6 plus 9 is 15. So this side is 15. Now, a lot of you would probably just jump with that, but I don't. 11 times 2 is 22. So if I subtract 7, oh, I got 15, which is actually a good confirmation that my arithmetic over here, my algebra was good. And so all 4 of these are 15. So my perimeter is just 4 of those 15s, or a total of 60 meters. Because notice it actually says meters right there. And last but not least, we have a parallelogram again. Interesting. And it says it's a parallelogram, and it says DE is the same as FG. Now, that's actually more information than we were needed to be given. We actually could have gotten that a little bit quicker, but it's all right. So I'm just going ahead and making something. These are both 5s and these are both 2, or whatever number. I guess it was 3. So we've got D, E, F, G. I made these the same angles and these the same angles, but it told me the distance from D to G over here is 3x plus 3. And it told me that E to F over here is 4x minus 1. And it just says, let's find the value of x. But just like we saw in the other ones, in a parallelogram, not only are these two sides parallel, they're also equal to each other. So I'm going to go ahead and subtract 3x from both sides. And then, of course, we can do one last step, which is add 1 to both sides. And I found out that x was, in fact, 4. And we just finished page 1 of our review. All right, I hope that was helpful, and I will see you back in class. Bye-bye.